Hello friends, and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds the height of a binary tree. Let us begin and first understand what exactly height of a binary tree means. There are two conventions to define height of a binary tree. In the first convention, we find the number of nodes on longest path from root to the deepest node. And in the second convention, we find the number of edges on longest path from root to the deepest node. We will follow the first convention. Let us see an example and find the height of a tree. In this tree, we have root node equal to 1. So, the longest path we can go is from 1 to 4 or 5. So, the height is 1 plus 1 plus 1, which is equal to 3. We can use level order traversal to find height without recursion. The idea is to traverse level by level. Whenever move down to a level, increment height by 1. Count number of nodes at each level. Stop traversing when count of nodes at next level is 0. Now let us see the algorithm which will assist us in this. Note that we are using a queue data structure. Also, we need a height variable to store the height of the tree. We initialize height to 0. Let us also take a sample tree to test our algorithm. Next, we push the root node, which is 1, into the queue. Now, we enter the first while loop. We have another variable node count which will store the number of nodes at current level. Here, node count is equal to 1 as we have only one node in the queue. Since node count is not equal to 0, we increment height by 1. So, height will now be 1. In the next step, we will dequeue all nodes of current level and enqueue nodes of next level. So, we enter the second while loop since node count is 1, which is greater than 0. We store the front element of the queue in a new variable node. Next, we dequeue the node from the queue. So, 1 will be dequeued. Now, we will push the left and the right child into the queue. Since node 1's left child is 2, we push 2 into the queue. Also, the right child is not null, so we push the right child, which is 3, into the queue. In the next step, we will decrement the value of node count by 1. So, node count will now be equal to 0. Since node count is not greater than 0, we come out of the second while loop. We continue the program with the first while loop. So, now node count will be equal to 2 as the size, which is the number of elements in the queue, is 2. Since node count is not equal to 0, we increment height. So, height will now be equal to 2. We enter the next while loop since node count is greater than 0. Now, node will point to 2. Next, 2 will be popped out. Now, left and right child of 2 will be enqueued. So, first the left child, which is 4, is enqueued. Next, the right child, which is 5, will be enqueued. Now, node count will be decremented by 1. So, node count will now be equal to 1. Since node count is greater than 0, we enter the second while loop once again. Now, node will point to 3. Then, 3 will be popped. Since 3 doesn't have any child, nothing will be enqueued. Also, the value of node count will be decremented by 1. Now, node count will be equal to 0. Since node count is not greater than 0, we exit the loop. Next, we continue the first while loop. Now, node count will be equal to 2 as there are 2 elements in the queue. Again, height will be incremented by 1. Since node count is greater than 0, we enter the second while loop. Again, node will now be equal to 4 and 4 will be dequeued. Since node 4 doesn't have any child, nothing will be inqueued. Moreover, node count will be decremented by 1. So, node count will now be equal to 1. Since node count is greater than 0, we loop again. Now, node will point to 5. Then 5 will be popped. Since 5 does not have any child, nothing is enqueued, and node count is decremented by 1. So, node count will be equal to 0. Since node count is not greater than 0, we exit the second while loop. We continue with the first while loop. Since the queue is empty, node count, which stores the size of the queue, will be equal to 0. Since node count is equal to 0, the if condition is satisfied and the value of height is returned. So, 3 is returned. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in our tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.